Hello guys, it's your favorite teacher, Godson, and you know what it is. This is Wits Lounge, Learning Made Easy. Today, we are going to be studying Faraday's laws of electrolysis. Yes, but before we get to that, if you haven't subscribed to my YouTube channel, please do. Just click the subscribe button there. It's not hard. Okay? Thank you. Now, what am I trying to say? Faraday's laws of electrolysis is actually built on the basis of the relationship between the masses of a substance deposited and the quantity of electricity passed through the electrolyte. We all know that electrolysis is defined as the chemical decomposition of a substance which is brought about by passing electricity through that substance in its liquid state. So note something, the chemical compound involved has to be decomposed, and if it is decomposed, it is broken down into neutral forms which are going to be deposited on both electrodes. So have this in mind. Now whenever you are dealing with electrolysis, electricity is passed, that electricity will cause a breakdown, and once the compound is broken down, the constituents will be deposited. That's why we need to understand Faraday's laws of electrolysis. As I said, it tends to show the relationship between the quantity of electricity, the mass deposited, charge. And with this, we get into the study. First law of electrolysis. Faraday's first law of electrolysis simply states that during electrolysis of a given compound, the mass of the substance deposited is directly proportional to the quantity of electricity passed through the electrolyte. I take it again. Faraday's first law of electrolysis simply states that during electrolysis, the mass of a substance deposited is directly proportional to the quantity of electricity passed through the electrolyte. Yes, the implication of this statement is if you have a higher mass, it is because more quantity of electricity was passed through it. If you increase the quantity of electricity, you increase the mass of the substance deposited. That's what we mean when we say direct proportionality. With that said, we are going to be putting down a mathematical expression of the law. Remember, as I said, it states that the mass of a substance deposited is directly proportional to the quantity of electricity passed through the electrolyte. So we have M directly proportional to Q. And as proper mathematics students, we should have noticed that to remove the proportionality sign, you introduce a constant. In this case, the constant is Z. So we have M equals ZQ. Now, what is Z? Z equals constant, and this constant has a name known as electrochemical equivalent. Yes, our constant Z is known as the electrochemical equivalent. So put this down. M is directly proportional to Q, and M is equals ZQ, where Z is the constant known as the electrochemical equivalent. Yes, this is how to mathematically express Faraday's law. And we see in the first law, we are simply relating the mass of a substance to the quantity of electricity. With this said, I would also like you to learn or have this in mind that Q is equals IT, meaning Q is equals current times time, because I is equals current and T is equals time. The implication is that if you have a question and you are not given the quantity of electricity, but you are given current and time, and you are supposed to relate it to the mass of the substance deposited, what will it become? Quite simple. M is going to be equals Z. Instead of Q, we now have IT. Now, we have two formulas. M is equals ZIT and M is equals ZQ. So put that down. These two formulas are used to illustrate Faraday's first law mathematically. Moving ahead, we'll get into the next concept. And what is the next concept? The fact that if I happen to make my electrochemical equivalent constant, it would be Z equals M over Q, which would now lead us to a new formula. M1 over Q1 is equals M2 over Q2. Hope this is understood. So as we see, in this case, Z is equals M over Q. Therefore, we will have M1 over Q1 equals M2 over Q2. To help you understand this a little bit more, please go and study variation. Yes, go and study variation. It's going to help you understand this more. Now, with that said, we move ahead. Having established this, you would also note that since Q is equals IT, what is this going to be? Instead of having M over Q, we are going to have M over IT. Okay, let me put that down here. I'm taking this away. Let me put this down here. So you have M is equals ZIT. Therefore, Z is equals M all over IT, which implies that M1 over I1 T1 is equals M2 over I2 T2. Okay, so we have that. We've gotten 4 formulas from Faraday's first law of electrolysis, and I'm going to put that down on this part of the board. So we have the first one, M is equals ZQ. Second one, M is equals ZIT. The third one, M1 over Q1 is equals M2 over Q2. And then the fourth one, M1 over I1 T1 is equals M2 over I2 T2. So please put this down. These are the formulas. Now, having established these formulas, if you are writing an exam, specifically for those that are writing an exam, and you are confused on where to use what law and where to use what formula, please listen. There are 2 major things you need to note down about where Faraday's first law is being used in exam questions. The first one is this. Whenever you have a question that is relating the mass of a substance to the quantity of electricity passed through the electrolyte, and in the question you are given electrochemical equivalent, you are expected to solve using Faraday's first law of electrolysis. I take it again. If you are given a question which involves the relationship between the mass of a substance deposited and the quantity of electrolysis passed through the electrolyte, with ECE, which is electrochemical equivalent, given, automatically you are going to be dealing with Faraday's first law. So don't get confused. We'll check out a question that has to do with that, and that is, right, what is the mass of a substance? What is, not just any substance but copper, what is the mass of copper deposited, given that 600 coulombs of electricity was passed through copper 2 sulfate electrolyte solution? What is the mass of copper deposited, given that 600 coulombs of electricity was passed through copper 2 sulfate electrolyte solution? Full stop. And you're right. The electrochemical equivalent of copper is 3.3 times 10 raised to the power minus 4 gram per coulomb. So let's get to solve this question. It should be very easy to solve. We have our formulas, and then, as we said, we are going to be applying Faraday's first law dependent on what we have in the question. Now, if you look at this question, we are asked to find the mass. We are given the quantity of electricity, and that's 600 coulombs. And what else were we given? Z, which is 3.3 times 10 raised to the power minus 4 gram per coulomb. Now, once you have a question, as we said, that relates mass, quantity of electricity, and you are given electrochemical equivalent, you are expected to use Faraday's first law. No other problem. I hope this is understood. And because of that, if we look at our formulas, which one of them has mass, quantity of electricity, and Z? And that is M equals ZQ. Chicken, now you have gotten your answer. M is equals, what is Z? 3.3 times 10 raised to the power minus 4 multiplied by 600 coulombs. And our mass is going to be 0.198 grams, because the unit of mass is grams. You can actually do this to check it out. And that's that. A quite simple concept. Got it. With this said, you could look at it again. I take it again. In this question, we expected to find the mass. We are given the quantity of electricity, and we have ECE. Faraday's first law is applied. So, which one of these formulas amongst Faraday's first law are we going to use? The mass, we don't know. We know our Z, which is 3.3 for copper, and the quantity of electricity is 600 coulombs. M is equals ZQ, meaning the electrochemical equivalent multiplied by the quantity of electricity. And this is what we have as our answer. Hope this wasn't hard for you to understand. So with that said, what is the second thing you need to note? The second thing to note when you are dealing with Faraday's first law, especially with respect to questions, if you have an exam question and you notice that you are relating different masses of the same substances to different quantities of electricity, it implies that you are going to be using Faraday's first law. I take it again, the second condition to understand or use Faraday's first law of electrolysis is the question involves relation between different masses of the same, emphasis, same substance and different quantities of electricity. The implication is that you're going to have to apply Faraday's first law of electrolysis. Let's try this question to help us understand this. Imagine you have a question and it says, the mass of copper deposited by 600 coulombs of electricity is, the mass of copper deposited by 600 coulombs of electricity is 0.198 gram. The mass of copper deposited by 600 coulombs of electricity is 0.198 gram. Given that 300 coulombs of electricity was passed through another solution of copper, salt, what is the mass of copper deposited? So we have that. In this case now, you are relating different masses of the same copper deposited by different quantities of electricity. What law are you going to apply? Faraday's first law. And amongst the formulas we are going to be using, the one that is going to be used is this one. Why? Because we are relating different masses to different quantities of electricity. If, for instance, we are dealing with just one mass in relation to the quantity of electricity and we had an electrochemical equivalence, we'll be using the first one. And if, for instance, we had different masses, but then we are giving current and time, we'll be using this last one. But in this question, we are giving quantity of electricity and mass. Different masses, different quantities of electricity of the same substance. Note the same substance. That's why we are permitted to use this. So the first mass of copper, which was given, is 0.198 gram. The second mass of copper is what we don't know. The first quantity of electricity is 600 coulombs, and then you have the second quantity of electricity as 300 coulombs. So what do? M1 over Q1 is equals M2 over Q2. What does this imply? The mass of the first one is 0.198 divided by the quantity of electricity is 600, which is equals the mass of the second one, which we don't know, and then finally 300. What should be done at this point? Cross multiply. Therefore, M2 is going to be equals 0.198 times 300, all divided by 600. If you divide this is 1, this is 2. Therefore, what you are going to have is 0.099 gram. And that's that. So you notice that it's a direct proportionality because when the quantity of electricity was halved, the mass was also halved. And that's that. Very easy to understand. I hope with these things you are able to solve any other question that has to do with Faraday's law. If you have any question with respect to what I just did, contact me or probably ask the questions in the comment section. You will be duly responded to. Thank you very much for watching. Remember, this is Wits Lounge. Learning made easy.